In this slidecast, we're going to talk about simulating waiting lines using queues. So simulation is a way that we can study the performance of real systems using physical, mathematical, or computer models. It lets designers of a new system estimate the expected performance before building it. So this can be helpful because it can lead to changes in the design that can improve a system, and we can do this maybe without going to the expense of building a system or working with things that are very, very dangerous. Now, system designers often use computer models to simulate physical systems. And an example is an airline check-in counter. And there's a branch of mathematics called queuing theory that studies such problems. So here's a case study with a hypothetical Blue Sky Airlines. And we'd like to have two lines, one of regular customers and one with frequent flyers. And if we assume there's only one ticket agent, we'd like to determine the average wait time for taking passengers from the waiting lines using different strategies. For instance, we could take turns serving the passengers from both lines, a frequent flyer, then a regular, and a frequent flyer. We could serve the passenger who's waited the longest. We could also prioritize that frequent flyers always get served before regular customers. So we've got our single ticket agent and our line of two kinds of passengers. And to run the simulation, we could keep track of the current time by maintaining a clock set to 0, and then we increment the clock to simulate 1 unit of time. And then during each interval of time, one or more of events could happen. We could have different kinds of flyers could arrive in line. The ticket agent could finish serving a passenger and start serving the next person in line. Either in the frequent flyer or the regular passenger line, or the ticket agent could be idle because there's no passengers to serve. And we can simulate different serving strategies by introducing a simulation variable called the frequent flyer max, and that value would represent the number of consecutive frequent flyer passengers served between regular passengers. And this variable would control. We could use this to simulate the different policies. If the frequent flyer max would be 1, then that would allow us to do every other passenger. If it was 2, then every third passenger would be a regular passenger. And if we had a really large number, then that means any frequent flyers would always be served before regular customers. So here's a UML diagram that shows the different elements of the system. We've got an agent, we've got passengers that are being served, we have the queue of passengers. This queue would have a passenger queue, and there's an airline check-in simulator program. It has a passenger queue. Here's a sequence diagram of our simulation program. We have our simulator, and we have our queue of frequent flyers and our queue of regular passengers. And this shows the interaction, the messages that flow between these different parts of the system and the actions that take place. We check new arrivals, and we can create new passengers and put them into the frequent flyer queue or into the regular passenger queue. Once we start to serve customers, the basic idea is we can check, and there'll be times when we can take frequent flyers and service them, and here's the case where we'll take regular passengers and service them. So study this sequence diagram to see how the simulator functions. Here's some UML diagrams that show the different classes and their methods and data fields. And then here's some relationships. This is the has a relationship in UML. So our queue class has a passenger queue, and our airline simulator has a passenger queue of regular passengers and frequent flyer passengers. Here are the data fields and the functions. And let's go back and look. I believe this is for the airline check-in simulator. So here's the data fields, what they mean, and the functions and their behavior. So you can stop this and study this diagram and look in your book to see how this simulator operates. Here's some more data fields for our passenger. Here's the queue of passengers and the other fields, and here are the functions. Here we'll continue with some more functions and behavior. Here's some internal variables that the simulator uses. And here's the header file for our airline check-in simulator. You can stop this and look at each item. And then here's the main routine for our simulator. We create a simulator object, we enter data, then we run the simulation and then output some statistics. And this is a way we can experiment with different strategies. Here's the header file for the passenger queue. And here we have a constructor and the getNumServed fields. Here's some more of this implementation. And here's the private data fields that have the queue of passengers. Here's our passenger header file. And then here's an implementation of the passenger class. Here's the passenger constructor. Here's the max time to process a passenger and the sequence number for passengers. Here's a random.h. This is helpful because it shows you how to use a random number generator when you want to do some simulations that require random numbers. And finally, here's the output for actually running the simulator. So I recommend you take some time and study this application, this example that's provided in your chapter, and this will give you a nice example that you can use to model some of the operations in labs that you're writing, and make sure you understand all of the C++ that's used to create this simulation and see how the simulator operates. And that's the end of this slidecast.